Hello, everyone, and welcome back to our multiplication with fractions activity. So we've got some pretty exciting stuff ready for us here, but first I want to go over some key terms or academic language that I think would be really helpful to us during this exercise. The first one I want to go over is whole numbers. Now, whole numbers are numbers or integers without fractions. So something like 1, 2, 3, or 4. So a number without fraction. So this could be 1, 2, 3, and so on and so forth. And the reason this is important with fractions is we might get a question that asks us to say, write 6/2 as a whole number. Oh, almost misspelled whole there, but that's all right. Now, how might I do that? How might I write 6/2 as a whole number? Well, let's explore that. So 6/2 as a whole number. One of the ways I can do that is I can take my denominator, which is my bottom number, and divide my numerator, which is my top number. So I can take 2 and divide 6 by it. So 6 divided by 2, see what I have. 2 goes into 6 3 times, and there's nothing left over for me. So I know that 6/2, or 6 divided by 2, equals 3. So my whole number in this case, 6/2, would be 3. Now, our next key term that I think would be very important, and that we see a lot of times often on tests, state testing, is mixed number. What is a mixed number? I'm sure we've all seen this before, wondering, what is a mixed number? Well, a mixed number is simple. It's simply just a whole number and a fraction together. So a mixed number is a whole number paired with a fraction. So that looks like something like 1 2/3, because we have our whole number and we have our fraction. 1 2/3 makes a mixed number. Now, why is this important? Like I said, it's something we might see on one of our tests. For instance, we could see, write 7/2 as a mixed number. Now, what is one of the ways we might go about doing that? Well, much like we did with the whole number, we could take our 7 and divide it by 2 and see what that gets us. Now, I know 2 goes into 7 3 times, because 2 times 3 is 6, minus 1, and I have a remainder of 1. Now, what does that mean? What does that remainder of 1 mean? Because I know this 3 means I have a whole number of 3. So what does the remainder of 1 means? Well, what it means is my whole number of 3, and I know my fraction was over 2, because that's what I divided it by. So my remainder simply goes all the way over here up on top. and it equals 3 1/2, and that's how I write 7/2 as a mixed number. Mixed because it has a whole number and a fraction all together. Now, our final piece of key language for this activity that I want to go over as soon as I erase this board. Man, oh man, would I need to get a bigger eraser, but that's for next time. Our next key term is an improper fraction. An improper fraction. Now, what that means is an improper fraction is a fraction where the numerator, and that's the number on top, where the numerator, so I'm also going to do a little bit of upwards, so that lets me know that this is the number on top, the one on top. Something that I think helps me out a little bit. It's not necessary, but if you think it helps you out, feel free to go ahead. But a fraction where the numerator is greater. I'm also going to put in parentheses here, or bigger, just as another adjective to use to describe the size of the number. That's what they mean when they say greater. They mean something that is bigger, a bigger number. That is greater than, which means it's bigger than, or equal to the denominator, which is that bottom number. The denominator is the bottom number. Oh, I messed up the spelling right there. D-E-N-O-M. Denominator. Equal to the denominator, the bottom number. So what this means is, if it's greater than, it could be 6/5. That is a improper fraction because the numerator is greater than the denominator. Or it could look like this: 7/7, because the numerator is equal to the denominator. These are examples of improper fractions. Now, the reason that's important is because the test might ask us to identify an improper fraction, or it might ask us to make an improper fraction a mixed number or whole number. So it might say, here, we'll erase these examples. 10/3 is an improper fraction. Solve into a mixed number. So our test might ask us something like this. And just like we've been doing before when we've been solving the whole number and the mixed number, we take our denominator and divide our numerator by it. So I'd go 10 divided by 3 and see what I can find. Now I know 3 does not go into 1, so I write down a 0. But 3 goes into 10 3 times. That's 3 times 3 is 9, minus 1, or minus 9 equals 1, a remainder of 1. And like we said before, this is my whole number right here, this 3, and this will be my numerator. So 3, denominator of 3, remainder of 1. So I've taken an improper fraction and I've made it a mixed number. But that is all for our vocabulary, at least for this lesson. Now, like I mentioned, we're going to be doing multiplying fractions. But how do we go about doing that? What do we do when we multiply fractions? Well, let's look at an equation first off. So say I had 2 over 3 times 2 over 5. What would I do? Now, in subtracting or adding fractions, sometimes we'd like to find a like denominator, or sometimes we'd need to regroup a whole number. But in this case, it's so much simpler. All we have to do is cross multiply. And what I mean by that is we take our numerator and our denominator and we multiply the number that's directly across from them. So in this case, I would take 2 and multiply it by 2, which would give me 4. And I take 3 and multiply it by 5, which would give me 15. So 2 times 2 over 3 times 2 over 5 would equal 4 over 15. So much simpler this way. All you have to do is cross multiply. Now, what do we do though if we have to multiply a mixed number? That's a pretty good question, and it's something that's going to come up. So if we have something, say, like 2 and 1/3 times 5 over 8. What do I do in this scenario? Well, much like when we did subtraction, we would often regroup. So we'd take away from our whole number and convert it into fraction form and add it. But we don't need to do that here because we're trying to take multiple whole numbers, not just one. So that takes a little too long. Instead, what we can do is multiply it by our denominator and add it to our numerator. This looks like this. We would go 2 times 3, our denominator, which would give us 6. So in essence, it would be 6 over 3, our denominator. And we would add that to our fraction 1 over 3. So just like regrouping, but we're doing it on a much bigger scale. Now that we have that, we can go ahead and times it to our fraction. So we go 7 over 3 times 5 over 8. And what does that give us? This gives us 35 over 24. And that gives us an opportunity to simplify, because right now this is an improper fraction. And even though our instructions didn't state to simplify, typically that's something you always want to try to do. So instead of dividing, I know that 24 is only going to go into 35 once. 35 is not big enough. I'm just going to subtract from it to get my whole number. So that would be 1, 24 minus 35, 11 over 24. And I can't simplify it anymore, so that would be my answer. That's how I would multiply a mixed number.